Hey guys, this is our last video of looking at solving trigonometric equations when the angle inside the function is being multiplied by some number. So, in part 1 we looked at sine, part 2 we looked at cos, you guessed it, here we're going to look at tan. So if you haven't checked out the other two first, I would recommend doing that. They will be linked down below in the description. So we can go through, in particular, in part 1, we go through the notion of a period of a function and also how we're changing the interval in a bit more detail than I probably will here. So, let's get cracking. First of all then, tan is a little bit different from sine and cos. Sine and cos both have a period of 360 degrees, which means it takes the graph 360 degrees until it repeats itself again. Tan has a period of 180 degrees. So the tan graph repeats every 180 degrees. So, say here, we were solving tan of theta is equal to some number n. Let's say our calculator would first of all give us this solution. So, if we wanted to go back to this solution, we would minus 180 degrees, or if we wanted to go forward to this solution, we would add 180 degrees. So in some ways, tan, even though it's a bit of a tricky function and not a very nice looking graph, in some ways it is the nicest one for when we are solving trig equations. It's nice and simple to get from one solution to the next. So, let's do a couple examples. Okay, first example then, we want to solve for tan of 2 theta plus 3 is equal to 0 for theta between 0 and 180 degrees to the nearest degree. So, we have to rearrange the equation to get tan 2 theta on its own. So let's do that first. So, if we've got 4 tan of 2 theta plus 3 equals 0, first move, take the 3 away. So we got 4 tan 2 theta equals minus 3, and then divide by 4. We've got tan of 2 theta equals minus 3 quarters. Okay, so that is the equation that we want to solve. Now, the next thing we're going to want to do is change the interval. So we've got theta between 0 and 180 degrees. In our function now, we've got 2 theta. So we're going to multiply the interval by 2. So we can get 0 is less than or equal to 2 theta, which is less than or equal to 360. So our values of 2 theta are allowed to be between 0 and 360. So, next, we're going to use our calculator to get the first solution. Now, because we're dealing with tan here, I'm not even going to bother sketching the graph. Once we get our first solution, we just add 180 or subtract 180, depending on our interval. So, if we did, well, we would get 2 theta is equal to the inverse tan of minus 3 quarters. Now, to the nearest degree, that gives us minus 37. So we've got a bit of a problem there. That is not in the interval that 2 theta is allowed to be in. So that doesn't actually count as a solution. So we'll just put a little cross next to that just to show 2 theta is not allowed to be minus 37. So to get into the interval that we want, which for 2 theta is 0 to 360, we're going to add 180. So, minus 37 plus 180. Now again, remember, we're doing that because the period of tan theta is 180. So minus 37, add 180 is 143. So that is the first value that 2 theta is allowed to be. So 2 theta can be 143. Again, because that is in our interval 0 to 360. So now we need to test what happens if we add another 180. Will that still be in our interval? And the answer is yes. So 143 add 180 is 323 degrees. So those are going to be the only two values that 2 theta can be. Now from that, we can get our two values of theta by dividing by 2. So 143 divided by 2 is 71.5, but we wanted this to the nearest degree. So that is actually going to be 72 and then 323. That was a comma, not a 1. 323 divided by 2 is 161.5. But to the nearest degree, that would be 162. So there are our solutions to the nearest degree for that one. Good times. Okay, second example, so we want to solve tan of 3 theta equals 1 for theta between minus 90 and positive 90. So we don't need to rearrange the equation, so the first thing we want to do is change the interval. So we got 3 theta, we need to multiply the interval then by 3. So we would get minus 270 is less than or equal to 3 theta is less than or equal to positive 270. So that is the interval that 3 theta is allowed to be in. So we can get our first value of 3 theta by doing the inverse tan of 1, which is going to give us 45 degrees. So that is certainly in our realm of values that 3 theta is allowed to be. So there's going to be quite a few here. So let's put 3 theta up the top. Now 3 theta is allowed to be 45. Now to find any others, we add 180 or subtract 180. So let's do the additions first. So 45 add 180 is 225. If we add 180 again, we're going to be above 270, so out of the region that we're allowed. So we're now going to have to do 45 minus 180. So 45 minus 180 is minus 135. Now again, if we were to subtract another 180, we would be outside of our limit. So these are the 3 values that 3 theta can be. So to get our values for theta, we change to green like we have every other time. So theta is each of these 3 values divided by 3. So, minus 135 divided by 3 is minus 45. 45 divided by 3 is positive 15. And then 225 divided by 3 is gonna be 75. So those are our three values for theta. Good times. Okay guys, that's it for this video. Hope you had fun.